Okay, in this lecture we're going to talk about evaluating rational exponents, and we're going to up the difficulty a little bit, because remember we've talked about rationals so far as being integers, which integers are rationals. Now what if we have something different to that, like we have, say, the simplest rational, which would be, say, 1 on n. Okay, what do we mean by this? Well, the interesting thing is, if I raise that to the power of n, and I will use our rules, this would be 1 to the n by n, which of course is a to the 1. Okay? Alright, so consequently, that leads us to a number of things here. Alright? This is suggesting here that a to the 1 on n is a number whose nth power is a, alright, because this is equal to a here. Alright, so that leads us to a little bit of a complication, because what if we have squared powers or even powers and we have odd powers? Now we have to treat those a little bit differently. Right, so if we have here an n is even, okay, if n is an even integer, okay, and we have a is greater than 0, okay, then clearly a to the 1 on n to the n is going to be equal to a, okay, because this would be the principal square root, because we find the nth root of a positive number, which is okay when n is even. If a was negative, then we'd have a bit of an issue. All right, and if it's odd, though, we don't have an issue at all. Regardless of what a is, right? So if in this case here, if we have a to the 1 on n and n is odd, okay, then a can be any non-zero real number. It doesn't have to be, all right, positive like in the even case. Okay. All right. Now, also we should note, of course, that if a is equal to 0, all right, then of course 0 to the 1 on n will still be 0. Okay. All right. So remember, we're talking about this then being the principal. All right, the principal nth root, the positive one. All right, so let's look at some examples. Okay, let's evaluate each of the following. Right, let's suppose that I have 36 to the half. All right, so what's 36 to the half? Well, this is looking for the principal nth root of 36. In other words, a number that multiplied by itself gives 36, and it must be positive, so it must be 6. Okay. What if I have this one, the negative 169 to the half? Well, what do we do with this one? Well, of course, the half is only being applied to the 169, so I'm looking for this, if you like, and the principal square root of 169 is 13, so we end up with negative of 13, because the principal square root of this would be positive 13. Okay? All right, if we look at the next one, let's suppose that I now want to do the negative, all right, of 81 to the half. Right, now notice that here a is going to be negative, and so we can't have that when, of course, n is even, which is it is in 2 here. So in this case here, all right, this is not a real number. Okay. All right. However, what if I was to do this one? What if I had the negative of 81 to the half? Well, that comes back down, of course, to the fact that we're applying the half power to the 81, so there'd be negative 9 would be the answer. Okay. All right, so now what if we do, what if I had negative 81 to the quarter? Well, this means we're finding the fourth principal root of 81, which of course is 3, and we'd have a negative in front. So it'd get a negative 3. Okay, what if we have negative 64 to the third? So we're looking now, notice that we have an odd, so we come here, it can be any number. So remember that it's still being applied to the 64, and the third root of 64 is 4, so it'd end up with negative 4 for that one. Okay. All right, so what if I have the 125 and we take the third power? Now notice that the third power is now being applied to the negative. Okay, so this is now, this one up here, n is odd again, but we have a negative number, and of course this will be negative 5. Because negative 5 by negative 5 by negative 5 will be negative 125. Right, so that's how we do those. Okay, so now in general, right, if I have a number a to the m and it's divided by n, this of course is going to be a to the 1 on n to the power of m using our exponent rules. Right, so let's do some examples of this. Right, again we want to evaluate. Right, so let's suppose that we have 64 to the 2/3. So this would be, of course, 64 to the third squared. Now the third root of 64, of course, is 4. 4 by 4 is 16 by 4 is 64. So I end up with 4 squared, which would be 16. All right, what if we have 25 to the 3 halves? This, of course, would be 25 to the half, and we've got to find the cube of it. And 25 to the half would be 5 cubed, which would be 125. Right, part C. Let's suppose we have negative 2. Let's make it negative 9. Negative 9 to the 3 halves. This would be the negative of, let's do a bracket here of 9 to the half cubed. So this would be negative, okay, of 3 cubed, which of course is negative 27. What if we have this one? Let's suppose we have 216 to the negative 2/3 this time. So if we have a negative 2/3, this is going to, of course, be 216 to the third to the negative 2. Alright, so 216 to the third is going to be 6. 6 is a 36. So it looks like it's 6 to the negative 2, which will be 1 on 6 to the 2, which will be 1 on 36. All right, and what if we have something like this? We have negative 100 to the 5 halves. Well, this would be, in fact, negative 100 to the half, and then we'd have to take it to the 5th power. Now, of course, we can't find the principal square root of negative 100 because this is n is even here, so this is not a real number.